One of the last things we're going to look at is graphing polar equations. As you practice these, it's going to become easier, but the best way to do it is to just do a bunch of examples. Let's begin with some that just contain r or just contain theta. As we look here at the first one where we just have a radius of 3, hopefully intuitively you recognize that it doesn't matter what theta is, the radius is always going to be 3. And if you remember, that's basically what a circle is. The radius of a circle, in this case, is always 3, no matter what our theta is. Likewise, if theta is always a certain value, in this case, our theta is 2 pi over 3, I know that my radius could be this long, my radius could be this long, my radius could be this long, my radius could be negative. But my theta is always going to be 2 pi over 3. So in that case, we have simply a straight line. In general, though, we typically have both a radius and a theta. So let's look at some examples here. One of the best ways to approach these is to plot some of the points, just like we did with X and Y when we were trying to figure out some basic shapes. And as we came to soon realize something that was Y equals X squared was the parabola, you're going to start to recognize some of these pictures as well. So if we're looking at R equals 2 cosine of theta, let's pick some representative points. When theta is 0, we know that the cosine of 0 is 1, so R is 2. When we plug in pi over 6, we get a radius of square root of 3. When we plug in 90 degrees or pi over 2, we get 0 because the cosine of pi over 2 is 0, and so on. And then as we move down and plot those points, so 0, a radius of 0, or I'm sorry, a theta of 0, radius of 2 puts us here. When we go theta is pi over 2, we end up here. There's a radius of 0. When we go to 2 pi over 3, which puts us over here, our radius is a negative 1, which puts us in the opposite direction. So there's lots that you can gain by just plotting a few representative points and then drawing a rough circle. If you want to check it in terms of the equation in rectangular coordinates, notice that we can take r equal to 2 cosine of theta. If we multiply both sides by r, we get r squared equals 2r cosine of theta. We can then rewrite that and convert it to rectangular coordinates in terms of x squared plus y squared equals 2x. Remember, we know that r squared is equal to x squared plus y squared, and cosine theta is x. And then we can complete the square. So we end up with x squared minus 2x plus y squared equals 0. And when we complete the square, we get x minus 1 squared plus y squared equals 1. And then we can do the same thing to sort of check our points by plugging in x's and y's. Another opportunity you have is to use symmetry in polar equations. An equation in both r and theta is symmetric with respect to either the pole, the polar axis, or a vertical line. And to determine those, it's symmetric to the pole, as shown in this first picture. If we replace r with negative r, and we get an equivalent equation, it is symmetric to the polar axis. In other words, what we picture is kind of the x-axis. If we replace theta with negative theta and get an irregular or an equivalent equation. And last but not least, it's symmetric with the line pi over 2. If we replace pi minus theta where theta was, and we get an equivalent equation. Looking at some examples here, I've put in a table that shows you some typical equations you might see. If you get something where the radius is listed as a plus or minus b sine of theta or cosine of theta, this is your typical shape. Here are your circles and spirals. You have roses, and this is the typical equation that you're looking for. And then these 8 figure shapes as well. And I believe those got cut off a little bit. Let me see if I can shift that picture up a little bit. Those equations will show up a little better there for you. So if this is the type of equations you see, you know the general shape. I've just put a few examples in here for you to look at. So for example, r equals 3 cosine of 4 theta. If we look at our table there, we see that that represents in table 2 an 8 petaled rose. Again, from this r a cosine of n theta. And so from that, we can determine some points on the table. And from that, you can then translate that into some of these points. I've listed several other examples here. We have r plus 2 equals 1 plus 2 cosine of theta. We know from our chart there that that is a limicon with an inner loop. Again, creating a chart with some of those points, and we can generate a rough picture of that graph. I hope that you'll take some time to practice with some of these. Again, they do just take lots of experience and lots of practice, but let me know if you have questions.